Welcome to another video on Kruskal Wallis test, that is a KW test. In this video, I am going to address two issues. One is for tied samples. Example, while we are solving a problem, if we see two samples like here 64 and here also 64 and here also 64. So in such cases, we have to treat that case differently. In case of a KW test, I will solve that issue. And one more case is large samples. A large sample means Kruskal Wallis test made for K groups 3. A number of groups only 3 are allowed in Kruskal Wallis test, and a number of sample, that is n is 5. So what if k is more than 3 and n is more than 5? So that is the case of large samples. I will address both issues in this video. I request to watch the whole video and comment your queries in the comment box. In my earlier video on Kruskal Wallis test, I have solved a problem and I have made an introductory video on Kruskal Wallis test. I hope you are familiar with that video. And now let us explore a problem. So here it is a problem. So here in this case, an analyst in the publishing industry wants to test whether the price of newspaper advertisement of a given sample size is about the same in 4 large newspaper groups. So in this case, there is an analyst in the publishing industry. He wants to test whether the price of newspaper advertisement on a given sample, the sample size, is about the same in 4 large newspaper groups, that is Group A, Group B, Group C and Group D. For that, they have taken a random sample of 7 newspapers from each group. That is Group A, Group B, Group C and Group D. They have taken a 7 random sample. Is selected and the price of an ad is recorded, which are given in this tabulation. So based on this, we have to derive. So do you believe that there is a significant difference in the price of an ad across 4 groups by Kruskal Wallis test at 1% level of significance? So here we want to test, is there any significant difference in the price of an ad across four groups using Kruskal Wallis test at 1% level of significance. So this problem looks like that we can deal this problem in ANOVA, but there is no, the distribution is not given, a normal distribution is not given in this case. So which means the problem is not which does not fulfill normality condition. So we cannot go for ANOVA. So one more counterpart of parametric test is that non-parametric test, Kruskal Wallis test. So we have to solve this problem using Kruskal Wallis test. So let us solve this problem using Kruskal Wallis test. Before that, let us see some of the steps that we are going to follow in solving Kruskal Wallis test. Firstly, as we know that we have to rank all the given numbers. From smallest to largest we have to rank. After that, we have to total the ranks of each sample. For example, in this problem we have four groups, right? Group A, Group B, Group C and Group D. So that we will call as R1, R2, R3, R4, T1, T2, T3, T4, like that. And we will total all groups rank only. So after that, we will apply that Kruskal Wallis test statistics. Thereafter, we will find a table value and we will compare our table value with the tested value. So this is the procedure we have to follow in a Kruskal Wallis test. So before going to solve this problem step by step, let us explore, let us formulate hypothesis for the given problem. See, they have asked here, do you believe that there is a significant difference in the price of an ad? Which means the price of an ad is not same for all the 4 groups. So our claim is the price of an ad across the 4 groups is not same. So here we have denoted that group 1 as mu1, group 2 as mu2 and group 3 as mu3 and group D as mu4 for the mathematical operation. So since they have asked, do you believe that there is a significant difference in the price of an ad across the four groups? So there is no significant difference between the price of an ads across four groups. So which means mu1 not equal to mu2 not equal to mu3 and not equal to mu4. This is our claim. So after claim we will take opposite of claim, that is complement. So complement is mu1 not equals to mu2 equals to mu3 equals to mu4. So which means the price of an ad across the four groups is same. So our claim and complement is ready. Now we have to formulate null and alternative hypothesis. Since complement contain equality sign, we will take complement as null hypothesis. So which means mu1 equals to mu2 equals to mu3 equals to mu4, which means the price of an ad across the four groups is same. And reminder is alternative hypothesis, that is mu1 not equal to mu2 not equal to mu3 and not equal to mu4, which means the price of an ad across the four groups is not same. So by this way we formulated our null and alternative hypothesis. So now let us go for the solving this problem. Before that, let us see what are the formula we have to apply for Kruskal Wallis test. So this is a formula for solving Kruskal Wallis test, which I have explained detailedly in my first lecture. So since there is a tie, if there is a tie, we have to find a correction factor. For finding correction factor, this is a formula. So after finding correction factor, we have to find adjusted Kruskal Wallis test. So for finding adjusted Kruskal Wallis test, this is a formula. So for correction factor, C is equal to 1 minus 1 in the denominator, n cube minus n. So Ti cube minus T. So other things are common except this T here. So T is Ti means number of ties. Say for example, if there are two samples are tie, so we will take that something cube minus something, and after that we will take plus, and we will consider as many ties are available in this problem. So that you will understand very well while we are solving a problem. So this is a formula we have to use for solving Kruskal Wallis test. Then let us focus on step number 1. So what is step number 1? Rank all the numbers. Very simple. We have to rank all the numbers. Before that, we have to take that problem into the meaningful format. So I have taken first group. Firstly, first group I have taken, and one more thing. Here I have ordered in ascending order, because since there are too many samples in this case, because 7 into 4, where there are 4 groups. In each group there are 7 samples, so 7 into 4, there are 28 samples in this case. So I have to take in ascending order, otherwise you will be in a confusion. So here in the group A, first smallest element is 45. I have taken is here 45, and next one is 48, second element is 48, and next one is 50. So third element is 50, and the next element is 57. So here 57. So thereafter 62, 65 and 70. So that is 62, 65 and 70. So for second group I have taken in the same manner. First smallest element is 55. I have taken 55 first. So thereafter 64, and thereafter 68. So after that 72, and after that 75. So after that 81, and lastly 90. So in the ascending order only have taken here. For the group C, our first smallest element is here 42. So next smallest element 48, and next one is 58, and next one is 59. So after that 60 and 61, and lastly 64. So this is this also I have taken in ascending order only, just to make it very smoothly. And last group, that is group D. So smallest element in group D is 64. So I have taken this in the first. So after that 69, 73, 82, 85. Where is 82 here, 85, after that 92, and lastly 94. So firstly I have taken all the given observation in ascending order. So after that I have to give a combined rank. So firstly I will seek for the lowest value. In group A, 45 is the lowest value. In a group B, 55 is the lowest value. In group C, 42 is lowest value. In group D, 64 is lowest value. So among all group, 42 is lowest. That is rank 1 is given to 42. So after 42, next element is 45. 45 is second next highest. So there is no 45. There is no tie for 45. So after that, after 45, there is a 48. So here 48 and here to 48. So since first rank and second rank is given, for 48 we can take it as a third rank, and this 48 we can take it as a fourth rank. Since there is a tie, we have to add what? Third and 4. So 3 plus 4, so which will be 7. 7 divided by 2. So 7 divided by 2 is 3.5. 3.5. So there is a one tie occur here. One tie occur. So since we have given what? 3 and 4th rank, we have combined to third and fourth observation. So then we have to give 5th rank. That is next highest value after 48 is 50. So which is given 5th rank. So after that 55 is next highest, that is given 6th rank. So after that 57, that is given 7th rank. So after that we have to search one more, any other elements. So after 57 we have 58, that is 8th rank. After that 59, that is 9th rank, and after that 60, that is 10th rank. So 61 and 11th rank. There are no ties for 58, 59, 60 and 61. So after 61, let us observe, is there any highest value to 61? So after 61, here we have 62. So that is given 12th rank. So after 62, let us observe, is here 65 and here 64. So we have 64. We can give next rank, but let us observe, is there any tie to 64? So 164, here also one more 64 is here, and in this group D, one more 64 is here. So which means there is a tie between these three samples in three groups. So we have already seen a tie, that is 48 and 48. This is a second tie, and since we have given 12th rank to the 62, so this we can take as a 13th rank. This is similar to how we did in our Man-Whitney U test, and this we can take that 14th position, that is a 14th rank, and lastly this we can take as 15th position. So 15th position. Now we have to add all together. So 13 plus 15, which is 27, plus the 15, 37, 42. Since we have added 3 observation, we will divide that 42 by 3 only. So when we divide by 3, we will get 14. So that is 64 is a 14th rank, here also 14th rank, and here also 14th rank. So by now we up to 15th we have given a rank. After 64, let us see, is there any highest value? Yes, of course there are so many values yet to assign rank. So after 64, here is we have 65, that is 16th rank, because we have already 15th position used. So after 65, there is 68 here, of course 68, that is given 17th rank. So after 68, let us see if there any other values. So 68, here 69, that is 18th rank. After 69, here we have 70, that is 19th rank, and after 70 we have 72, that is 20th rank. So after 72, 73 is here, that is 21. So after 73 we have 75, that is 22. So after 75 we have 81, that is given 23. 81 after 82, that is 24. So after that 85, that is 25. So after 85, we have 90, that is 26. After 90, 92, 27. So lastly 94, 28. 94 is a 28 rank, and number of sample in this tabulation is, as I told you already, 4 into 7. We have 4 groups. In each group we have 7 observation. Totally we have 28 samples in this matrix. So we have given 28 rank. So this is how we have given ranked all the numbers. This is a little bit tedious because since we have large numbers in this case. So after this everything will be easy. So after numbering all the numbers, all the samples, after ranking all the samples, now let us go for second step, that is total the ranks of each sample. So we have 4 sample, 4 groups, group A, group B, group C, group D. So respected group we will take a rank, total of each group rank, that is 2 plus 3.5 plus 5 plus 7 plus 12 plus 16 plus 19. So which is equals to 64.5, and group second total is totally 128, and group C total rank total is 56.5, and lastly group D total rank is 157. So by this way we finished say step number 2 also. Now next step is testing Kruskal Wallis test. So you know that the formula, firstly we have to find H using the primary formula. So that is Kruskal Wallis test. So here I have replaced all the elements to the formula. So here this is common, 12 is common, and in the denominator n. So n we have 4 groups, and in each group you have 7 sample. So total is 28 samples are there here, 28, and here this n is also 28, and plus 1 is common. So Ri, which means Ri we have 4 groups, so which means rank of 1, rank of 2, rank of 3, rank of 4. So we can take up to 4 values here. So rank of 1 is 64.5. Here this is 64.5, that I have taken in square, in the denominator 7, because we have 7 sample in the first group. In all the groups we have 7 sample. There is no unequal sample size in this case. And in the second rank, second group rank, 128, that I have taken in square, in the denominator also 7, because ni number of sample. In the third group rank is 56.5, so that is also taken in the square, in the denominator 7, and lastly 157 square in the denominator 7. So here 3 is common, and in the, as I told you, n is 28 samples here, plus 1. So this is I have replaced all the elements to the formula, just I have replaced. After that I am going to simplify that formula. So here 28 plus 1, 29. 28 into 29 will be 812. So here 64.5 into 64.5 divided by 7 will be 594.32. Here 128 into 128 divided by 7, 2340.57. So here 56.5 into 56.5 divided by 7 will be 456, and here 157 into 157 divided by 7 will be 3521.29. So here 29 plus 1, 28 plus 1, 29. 29 into 3 times will be 87. So this is how I have simplified. In the next step I will simplify furthermore. So this is 12 by 812. So 12 by 812 will be 0.014778. So all together added all together is 6912.18. So this is 87. So in the next denominator I will multiply this 0.014778 into 6912.18. That is that I will get 102.15, and I will subtract that 87 in the next step. So totally H, I got that Kruskal Wallis test statistics is H 15.15. So this is the result we obtained by replacing into the formula, that is Kruskal Wallis test formula. So the task is not over yet because there is a tie between the samples. So when there is a tie, we have to treat it differently. So when there is a tie, we have to find correction factor. Before going to finding a correction factor, we have to find some more things here before we are going to apply into the formula. That is from the above calculation, we see that there are tied ranks. There are tied ranks. So let us see how many tied ranks. That is number of groups of tied ranks. Let us find how many number of groups the tied ranks. Here 3.51 and 3.52. This is first group. One group is 3.5, and as I told shown you already, one more group is 14. That is 6 for 64 we have given, and here also 14, and here also 14. So we have two groups. Number of groups of tied rank is 2. R is equal to 2. That is 3.5 and 14. Two groups we have. And number of times group 3.5 of tied ranks occur. Let us find number of times group 3.5 of tied ranks occurs. That is T1, which I have made a simplification for applying formula. So how many ties in the group 1? That is T1. So as I told, as been seen here, we have 3 ties for 3.5. So 3.5, 3.5, that is 2. Number of times group 3.5 of tied ranks occurs is 2. So one more group is there, that is a number of times group 14 of tied ranks occur, that is T2. T2 14 is 3, that is 1, 2 and 3. So 3. So 14, there is a 3 ties in the 14th group, and in the 3.5 group there are 2 ties. So since a tie occurs, therefore we have to go for correction factor. So for finding correction factor, we have to use the formula. So the formula, as I told you already, so this is a formula we have to use. So this is information I derived from tabulation. What is that? This information which is useful for applying to the formula. Now let us replace this into the formula. Before that, let us see formula. Here n is 28, number of sample in this case is 28, and here ti we have t1 t2. We have identified 2 ties, that is first tied group and second tied group. So ti we have 2 ti. So now I will just apply it to the formula, then it will be more simpler. So here C same, 1 is also same, 1 minus 1, 1 is also here, 1 is also same. In the denominator n cube, n number of sample in this case is 28. So 28 cube minus n is 28. 28 cube minus 28. So here Ti cube means first tied group. First tied group is 2. Here 2. So that is 2 cube minus 2. So Ti minus T. T number of times 2 here. Ti is 2. So 2 cube minus 2 plus second one more tie we have, that is 3. That is 3. 3 cube minus 3. If there is one more tie, we have to take, like after taking plus, we have to take t minus t only, t cube minus t only. So this is how I have replaced the given extracted information from the tabulation. So since there are only 2 groups, I have applied to here. So now I will simplify this formula. So 28 cube, that is 28 into 28 into 28 minus 28. So that is that will be equals to 21,924. So this is 2 cube minus 2, 3 cube minus 2. So I could have simplified there only. So in the next step I have simplified this. So this 2 cube, 2 into 2 into 2, 8, minus 2, 6. and plus 3 cube, 3 into 3 into 3, that is 27 minus 3, 24. So I will take this to next step. Next simplification. So 6 plus 24 will be 30. So I will take it to into next step, that is 1 minus, so 1 by 21,924 into 30, that is firstly we will divide 1 by 21,924, thereafter I will multiply that into 30. So finally I got that 0.0013. So now finally I have to find a correction factor. So correction factor is C is equal to 0.9987. So we found correction factor. So after finding this correction factor, we need to proceed further to find the adjusted Kruskal Wallis test. So this is a formula for finding adjusted Kruskal Wallis test. So we have already found that H, that is Kruskal Wallis test, and correction factor HC we have found already, and now this is that result. H is in this case H15.15 and correction factor is 0.9987. Now we are gonna divide that H by correction factor. So once we divide H by correction factor, we will get that adjusted Kruskal Wallis test. Now we have to consider this as a tested value. Rather than this as a tested value, I will consider this as a tested value because this is a case of ties. Two groups of ties occur in this case. So now let us go for making a decision. Before that, one more thing we should keep in our mind. So before coming to large sample, I have ensured that in the initial of this video only, I will solve the issues of a large sample. So look at this table. This is a table of Kruskal Wallis test. Firstly, Kruskal Wallis test table. So here we can only encounter a number of groups as 1, 2, 3. That is number of groups we can entertain only 3, and in that too, in each group we can only entertain 5 sample. So here N1 is highest sample is 5, and even in N2 highest sample is 5, even in N3 highest sample is 5. So which means up to group 3's, that is K is equal to 3, and even in the each group we can only accommodate 5 sample. So this is only possible solution we can give in the Kruskal Wallis test. But in this case, let us see that problem. So in this case, you may see here. So in this case, you can look at here. We have 4 groups. There are no 3 groups. 3 groups are allowed in the case of Kruskal Wallis test. But here group A, group B, group C, and group D. We have 4 groups. So since there is 4 groups in the using a Kruskal Wallis test, we cannot consider table value of Kruskal Wallis test for this. And one more thing, there are 7 samples in each group. See 1, 2, 3, 4, 5, 6, 7. So in each sample there must be only 5 sample in each group, but here 7 samples and 4 groups. So how to deal this case? So that is the case of large sample. The case of large sample in the Kruskal Wallis test. So large number of samples, that is K greater than 3, or for large sample size, that is Ni greater than 5. As I shown you in that problem, the distribution of test statistics under null hypothesis is well approximated by the chi-square distribution. So chi-square distribution rather than KW test distribution. So that is in the chi-square distribution K minus 1 degree of freedom. We will see for K minus 1 degree of freedom. So when the number of samples of observation per sample are such that we can't use KW table, as I shown you KW table. Then we use X square table, that is chi-square distribution table for critical value of test statistics. So except this, other things remain same. So here groups are 3, k is 3, and number of samples is 5. We cannot accommodate this case. Then we have to go for that what I told you, that chi-square distribution. So this is a chi-square distribution table, that is X square table. Up to 30 degree of freedom I have copied and pasted here, and we can see up to 100 degree of freedom. So in this case, our since all sample sizes n1 is 7, n2 is 7, and n3 is 7, exceed 5. So exceed 5 means KW test only accommodate 5. So which exceed 5, the test statistics, that is HC, that is a Kruskal Wallis test, is approximated by chi-square test. So for chi-square test, we will encounter that k minus 1, 4 minus 1, and 3 degree of freedom. Why I am getting 4 minus 1 is we have 4 groups, that is A, B, C, D. So that is a k number of groups is 4. 4 minus 1. So degree of freedom is 3. Okay. So for this 3 degree of freedom, we compare calculated test statistics of HC with the critical value of X square. Since we are unable to use KW critical value table value, we go for X square table. So the critical value of X square with 3 degree of freedom at 1% level of significance is 11.34. So let us see, this is a degree of freedom 3, and 1% level of significance is this. This is 1% level of significance, and our interested value is this 11.34 at 3 degree of freedom. In chi-square test, we will look degree of freedom for groups, not for sample. So 11.34 is what is a tested value. So this is how we obtained p-value in the Kruskal Wallis test for large sample cases. So after obtaining everything, the table value, and solving tied issues and large sample case, everything. So now finally we are in the decision at last. So here we need to compare our adjusted Kruskal Wallis test, that is adjusted Kruskal Wallis test statistics is 15.15, but Kruskal Wallis test statistics is 15.15, 15.15, but we have found correction factor, and after that we have divided Kruskal Wallis test statistics by correction factor, and adjusted Kruskal Wallis test statistics is 15.17, and our table value we just obtained from that chi-square table. So that is table value is 11.34. So since adjusted Kruskal test statistics is greater than the critical value is 11.34, whereas tested value is 15.17. So we reject null hypothesis. In my introductory video, I told you that tested value must be lesser than the critical value. Then only we will accept null hypothesis. Otherwise, we will reject null hypothesis. And there is a support the alternative hypothesis. We reject null hypothesis and support alternative hypothesis at 1% level of significance. So finally, we can conclude that samples fail to provide us sufficient evidence against claim. So what is our claim? Price of an ad across 4 newspapers is different, but samples fail to provide us sufficient against our claim, against the claim. So we may assume that the price of an ad across 4 newspapers is different. So this is a decision finally. So you for practice, I have given a problem. You can take the screenshot for a practicing problem. In this problem also there is a tie here. In the condition A, 3 is there, and in the condition A only one more 3 is here, and in the here condition B 8 is here, and in condition AC 8 is here. So repeated tied case you may solve this also. So one more problem is also there. In this problem also there is a tie. You can take screenshot of this also. So this is my reference material for referring this video. Thank you so much for watching this video. Do subscribe to my Vision Academy YouTube channel.